Hi, and welcome to this review of Unit 1, Coordinate Geometry. This is Miss Murdoch, and I'll be talking you through all of the review problems in your packet. So you should be watching only after you've completed the problems yourself. You can use this video to check your work, make sure that you listen closely, and take notes on anything you may need to remember for the upcoming test. As Dory says, just keep studying, 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 because the more you practice, the stronger your skills will get. So the first example we've spent some time looking at in class, but if we zoom into number one asked, which of the following lines is parallel to the line negative 2x minus 8y equals 24? A really important key word here is this word parallel, which we should all recognize and immediately think same slope. So when we find a line parallel to this given line, we're looking for one of these answer choices to have the same slope as the line given to us. The line given to us, though, it's not easy to see what the slope is yet. And that's because we don't have it in a form, like slope-intercept form, where we can easily identify the slope. This is the general slope-intercept form. In that form, slope is always written next to x, the coefficient of x. So if we get that form, we should be able to quickly look at it and identify the slope. So for this example, the first thing we have to do to get it in y equals mx plus b form, or solve for y, is to move the x term that's on the left side, this negative 2x, to the other side. The way we move the x term is by using its additive inverse, so that's same number, different sign, which means that these cancel out. On the left, what we're left with is just negative 8y, and on the right, we have 24 plus 2x. Now these are not like terms, so they can't be combined, so we're just going to bring it down as 2x plus 24. And now we almost have y by itself, which is again what we want, but we need to get the coefficient, negative 8, away from the variable we want to isolate, which is y. So to get y by itself, we're going to divide both sides by negative 8 to eliminate that coefficient. Negative 8 divided by negative 8 is 1, so on the left side we're left with just y, and on the right we have to divide each piece by negative 8. So we have 2 divided by negative 8, which is negative 1/4, and we still keep that x. And we have positive 24 divided by negative 8, which gives us negative 3. So this is our new rearranged equation. It's the same as the original equation, but in a form that will help us quickly find the slope. So again, when we find the slope in slope-intercept form, the slope is what's written right next to x. So when we look at this, we should be able to quickly identify that the slope is negative 1/4. If you needed help simplifying 2 divided by negative 8, always feel free to use your calculator to do that. Be sure that you type it in order. It's top divided by bottom, or in this case 2 divided by negative 8. And if you don't get the simplified form of the fraction, you can press math, enter, enter to see it from the decimal form into a fraction. So we do get the slope here, and we're not done yet, because if we take a look at our answer choices, none of these are in slope-intercept form either, or even point-slope form, both of which would help us quickly identify the slope. So what we have to do in these problems is go through and check using the same process, move the x term to the opposite side of the equation, and then divide by the coefficient to get y by itself. And actually, I just noticed when I looked more closely that letter C, option C here, does have slope-intercept form. Again, we're looking for the coefficient of x, or the number next to x. And this one we can quickly identify because it's in slope-intercept form. It kind of lines up with y equals mx plus b form. And we see that the slope here is -4 for this line, this equation that we are given. And since that's not the same slope as the line we were given, we can rule out answer choice C. If we try another answer choice, like choice A, I notice that the x term has already been moved to the other side of the equation. So the only thing we have to do to get y by itself is divide by 4 on both sides, which will leave us with y equals on the left. And on the right, remember the coefficient is 1 if none is written. We have -1/4 x, and 16 divided by 4 is 4. So this is our answer in slope-intercept form. I'm just realizing now that this answer choice is slightly different than the one you were given. So if your sheet said choice A was 4y equals -x minus 12, you would have gotten an answer of -1/4 x minus 3. And that might sound familiar, and it should, because that was the answer choice. That was the equation of the line that was given to us. And in class we actually spent some time talking about how if we were getting the exact same equation, that would be slightly different. So this is an updated, better answer choice to have because now there's no problem with the problem. So in this example, we found an equation now in slope-intercept form, where we should be, again, easily able to see, because the slope is what's written next to x in the slope-intercept form, that the slope is -1/4. And since that is the same as the slope that was given to us, this is the correct answer choice. If I was taking this test, I would definitely go through and solve the other two examples, the other two answer choices as well, to make sure we found the right answer. And in a moment, I will pause and do that work and press play so you can then see that worked out. But for right now, we should be fairly confident that we've found our answer because it had the same slope. And again, our questions had to find the line parallel to that given line. All right, so I'm going to pause to check and do the work for B and D to make sure that we don't have more than one correct answer choice. You can press pause right now to try it on your own if you haven't already, and then press play when you are ready to check. So to solve for y in answer choice B, we do have to move the x term to the other side. So first thing, I'm going to copy this over. And to eliminate the x term from the left side, we use its additive inverse, which is the same number, different sign, on both sides, which means these terms cancel out. And we're left with 8y equals 8 plus 2x. And then when we divide by 8, the coefficient of y on both sides, we are left with y equals 1/4 x plus 1. Now, this is a tempting answer because it looks kind of similar to the slope that we wanted. However, this is a positive 1/4, so this is not the same slope as our given line, so it cannot be choice B. I'm going to change color for D. And when we look at answer choice D, again, we have to eliminate the x term from the side that the y is on. So we use its additive inverse on both sides, and we bring everything else down. Since these are not like terms on the right side, I just bring those down. If you wrote 16 minus 8x, that would also be valid. Just make sure you keep the signs with the correct numbers, and the commutative property tells us that we're okay to rearrange them. Again, we have a coefficient next to y, so we have to divide both sides by that coefficient, and when we do that, they cancel out. and we're left with y equals negative 8 divided by negative 2 is positive 4x, and positive 16 divided by negative 2 is negative 8. Now, if you can, think about why this may have been a tempting answer choice, and press play when you're ready to hear the answer. So what's tempting about this answer choice is that it's actually the opposite reciprocal of the given slope. Remember, our given slope was negative 1/4. Its opposite reciprocal is this positive 4. Remember, reciprocal means that we flip the number over. So in the case of negative 1/4, if it was flipped, it would be 4/1. This makes it a reciprocal. To make it opposite, we would change the sign so that negative becomes a positive, and these are opposite reciprocal slopes. Positive 4 divided by 1 is just 4, which was the slope that we were given here, which makes this a tempting choice, because we often hear opposite reciprocal slopes as well as same slopes, but we must know that in this case, because we have the word parallel, that what we're talking about is a line with the same slope, and if we had had perpendicular, choice D would have been our answer choice, but that was not the case here, so it is not choice D. Alright, we're going to move on now to question 2, which says the endpoints of a line segment are A, 7, negative 8, and B, negative 3, negative 4. Determine the coordinate of the midpoint of AB using the formula. Check your work using the graph. And a small typo here, this should say coordinates of the midpoint AB. And we should recognize that when we hear this word coordinates, what we're looking for is an XY ordered pair, especially since they talked about a point, specifically the midpoint of AB. So the first thing we should do when we are given these quantities that represent a place on the graph is definitely we want to plot those so that we can see and check our work. So to plot the point A, I always start at the origin, and since the x coordinate tells me to go in the positive direction 7 times, I move to 7, and the y coordinate negative 8 tells us to go down 8 places. I'm going to move my work around a little bit. This is kind of what my eye is doing. I go from negative 7 down to negative 8, and this is where we'll plot point A. It's a really good thing to always make sure that we are labeling our coordinates as well. So since this was point A, I'm going to label point A. The next point is B, negative 3, negative 4. So that ordered pair tells us to go to the left negative 3 and then go down negative 4. Now, they specifically tell us to determine the coordinates using the formula. So this is a formula that must be memorized, but the midpoint formula, if you're going to expand on what we know, is that it's the two x values, so x1 plus x2, divided by 2. That's going to be our first, or our x coordinate. And the second part of that formula is the y value, which is found by adding the two given y values and dividing that by 2. And this gives us our xy pair that is the midpoint of this segment. So the two given x values, if we again maybe want to restate them over to the side, so we had the first point 7, negative 8, and the second point negative 3, negative 4. So both of these are xy pairs. It's sometimes helpful to label them. It doesn't matter which one we call the first or the second point in this case, because from A to B or B to A, the midpoint is the same. So the first part of our formula said to add the two x values, which were 7 and -3, and divide that by 2. And the second part of our formula said that we should add the two y values, which are -8 and -4, and divide that by 2 to get our ordered pair. So for our x-coordinate, we have 7 plus -3, which is 4, and when we divide that by 2, we get 2. And for our y value, we have -8 plus -4, which is -12, and when we divide that by 2, we get -6. So our ordered pair is 2, -6, and we can plot that by going to the right 2 and then down 6, and we see that point here. It's not a bad idea to connect your line segment to take a look at what that looks like. Drawing on my screen right now, you can tell that line doesn't look too great. There we go, I was able to use my technology effectively to make a better line here. And you can check by taking a look at the big slope triangle, which would be from B to A, either going down 4 and to the right 10, or you might have gone to the right 10 and down 4, and either way your slope triangle is completely valid. Either way works. Since I went down 4 and to the right 10, I'll take a second to also check what my slope triangle would be from the midpoint. So if I go to the midpoint, if I go to the midpoint from B, I'm going down 2 and to the right 5, down 2 and to the right 5. So this tells me that this point that we found using the formula definitely is correct, since it was the same distance, going down 2 to the right 5 and down 2 to the right 5. Not all problems can you feel 100% confident walking away from, because not all problems have a way to check. But this was one that you can definitely walk away feeling confident, because you have two ways to find your answer. The first time we did it using the formula, and then we're able to check using the graph. Alright, moving on to problem 3, which says triangle ABC has vertices A, -2, 0, B, 3, 5, and C, -2, 5. You can see as I read that problem, I was thinking about where these points are, and as I started plotting multiple points, I realized I really need to have those labeled so that I can see which one is A, B, or C as I continue the problem. The question here asks, what is the length of the hypotenuse of the triangle to the nearest tenth? Notice that I've underlined the question and I squiggled any rounding. It said to the nearest tenth. An important action word here, or vocabulary word really, is the hypotenuse, which we should know is the side across from the right angle in a triangle. So wherever the right angle is, the hypotenuse is the side across from it. So in this triangle, the hypotenuse is going to be the side across from the right angle, which is located at C. And so the hypotenuse is going to be the side AB. So again, hypotenuse is going to be side AB, or line segment AB. There are two ways that we've learned to find the length of a line segment. So when we hear that word length, you might think of the Pythagorean theorem, a squared plus b squared equals c squared, or you might think of the distance formula, which is somewhat more complicated but absolutely a valid way to find the length or distance of a given line segment. since we've been focusing on the Pythagorean theorem in class, that's what I'll go through in this review. However, if you want a review of the distance formula, feel free to go back to that video. So in the Pythagorean theorem, remember that C is always the hypotenuse. So C is going to be the side that we are trying to find in this case, since we're trying to find the hypotenuse. And when we refer to A and B in this formula, we're talking about the two sides of the triangle that are not the hypotenuse. They're what we refer to as the legs. So we need to know the distance for the other two sides. And in this case, it's actually kind of nice because we can count 3, 4, 5 the distance easily without having to use another slope triangle to find these sides, because they happen to be vertical and horizontal lines. So those kind of scalloped lines that you see on the side are what I'm using to count the distance from A to C and from point C to B. And in this case, they both happen to be 5. So both A and B of this triangle, the legs of the triangle, are 5. Again, C is the unknown here. It's our hypotenuse. I'm going to call that X since it's an unknown. Classic variable choice. You can use any variable you like. If you want to stick with C, you're more than welcome to. So we have 5 squared, which is 25, and 5 squared again, still 25, equals x squared. We simplify each side of the equation first, so I'm getting 50 equals x squared. And to eliminate the exponent of 2, we're going to use a square root, which cancels that out, and we do the same thing to both sides. And if 50 was a perfect square, we'd have a nice, neat answer. But I'm going to open up my calculator on the side right now, and we type in the square root of 50. And the answer I see on my calculator is something like 7.071, there's my 106, and it keeps going. Since 50 is not a perfect square, the square root of 50 is an irrational number. I remember that in the question it said to the nearest tenth, which is 1 decimal place away from the decimal point. I find my number that I want, I look next door. Since it's 5 or more, I add 1 to 0, which gives me 1, and we get an answer of 7.1 for x. And that was the side that we are trying to find. So the hypotenuse of the triangle, if we want to give a full answer, 7.1 is the length of the hypotenuse of the triangle. And so this would be our final answer. To check this answer, there's really not too much we can do besides making sure we go back through our work very carefully, make sure that we counted. A good way to check might be cover up your work and do the problem again, see if you get the same answer. You could also go back and use the distance formula if you wanted to check that way. But there's nothing we can substitute back in to make sure that we got it right. So please make sure you're taking your time, counting and plotting correctly, and using A, B, and C in the right places when you substitute in. Now we're going to move on to number 4, which says triangle XYZ has vertices x, -2, -4, y, 2, 4, and z, 4, -2. And we are asked to justify that triangle ABC is both an isosceles triangle and a right triangle. So when the question asks us to justify, we want to make sure that we are explaining our answer really thoroughly in words. The structure we used in class was because, work shown, what the work means, and therefore our conclusion. So in this case, we're asked to do two things to justify that the triangle is both isosceles and a right triangle. So these are both some action words that should spark ideas in your head as soon as you see those words. Let's start with the isosceles part. Isosceles, we should know that that means that two sides of the triangle are congruent. And actually, while I'm thinking of that, let's draw those lines to show our nice triangle. So I drew in the sides of my triangle, and again, with limited technology, my lines could definitely be neater. I definitely recommend you using a ruler on your paper. So we're looking for two congruent sides to prove that this is isosceles, and just by looking at this triangle, it's kind of hard for me to tell if the two sides are congruent. But I know that congruence has to do with distance or length, and there are two ways that we know to check for distance, or to precisely measure distance, really. And if you go back to question number 3, we saw an example for finding the length of a line segment. And in this case, we can use the same method, which is using Pythagorean theorem, a squared plus b squared equals c squared, to find the length or the distance between 2 points. So since each side does not currently make a right triangle, we use our slope triangles to create a right angle. For example, if I want to find the distance between the points y and z, I'm going to make a slope triangle going from point y to point z. And let's use technology. Hopefully helps me out here. So following the straight lines, I went to the right 2 and then down 6 to find the distance from y to z. And it's important to stay on the straight lines because now we have a right angle, and we can use the Pythagorean theorem, since that's a right triangle, to help us find this side. So using Pythagorean theorem for side yz, we would say 2 squared plus 6 squared equals our unknown side, which is the hypotenuse of the slope triangle we've created, x squared. We can solve this by simplifying each side. We get 4 plus 36, which is 40, equals x squared. And to find the length of that side, we're going to have to take the square root to eliminate the exponent, and we find that that side, yz, has a length of radical 40. You could simplify and make this a decimal, but since I know that 40 is not a perfect square, I like to leave it in radical form because that's actually more precise. So we know that side yz has a length of radical 40. If I look for another side in this triangle, again, I'm trying to find the two sides are congruent to show that it is an isosceles triangle. I look for the slope triangle again, so I'm going to make a new slope triangle for the side xz. And to get from x to z, I'm going to the right 6 and then up 2. So I like to label that 6 and 2. And now we do again have a right triangle, which we can use the Pythagorean theorem and find the side that is missing, which is the hypotenuse, or side xz of this triangle. The way that looks for this one, xz, is again 2 squared plus 6 squared equals, let's call it y, side y for now, a different variable. And if this looks familiar, you're not going crazy. It is really familiar because it looks a lot like what we had for yz. So this may be a clue that we are going to have two congruent sides, which are yz and xz. If you simplify this new equation on the left side, you will get 40 equals y squared, and to eliminate that exponent we do the square root on both sides, which means that the exponent cancels out and we're left with y equals the square root of 40. So that means that the side xz also has a distance of radical 40. So showing these two sides are the same, and we can write this using notation like the distance of yz equals radical 40, and the distance of xz equals radical 40. We now have the work shown to prove that two sides are congruent, but we're not done because we haven't justified yet. So a correct justification for this problem would look like this. Because YZ, line segment YZ, is congruent to line segment XZ, these two sides are congruent, therefore triangle XYZ is isosceles. Now, again, we're only proving this part so far, and we're not done with the problem, but this justifies that triangle ABC is isosceles because we have our sentence explaining it as well as the work shown that supports our justification. Again, though, we are not done because we have not justified that it is also a right triangle. When you hear a right triangle, you should think about a triangle that contains a 90-degree angle, which means that two sides are what we call perpendicular. And when we say perpendicular, you say opposite reciprocal slopes. And all of these things should come to mind as soon as you hear a right triangle. 90 degrees, perpendicular, perpendicular, opposite reciprocal slopes. And as soon as you hear this word slope, you're thinking, I need to find the slope and prove that they are opposite reciprocals in order to prove that this is a right triangle. It's kind of like you're a lawyer fighting a case. You have to prove that this is true. There is a slope formula which you can use to find the slopes, but in this problem we've already drawn slope triangles. So again, notice here for YZ we made a slope triangle of going to the right 2 and down 6. We can use this to find the slope of YZ. All slopes are rise over run, so the up and down movement here was we went down 6 and to the right 2, which if we simplify it gives us a slope of -3. So again, to find or to prove that two slopes are perpendicular, we need to know that they're opposite reciprocals. So we don't need just one slope, but we need two slopes. The slope for XZ, we can use our other slope triangle here, which I did in red, which was, for the slope, if I'm going to label it, let me get my pen here, the slope of XZ is that we went up 2 and to the right 6. If we simplify this fraction, we get 1/3. And now we want to ask ourselves, are these opposite reciprocals? Since the sign has changed, they are indeed opposites, and since the reciprocal of 1/3 is 3, and conversely, the reciprocal of 3 is 1/3, yes, these are opposite reciprocal slopes, and this does prove that the triangle we were given, triangle XYZ, is isosceles. So our work is there, but again, because they said we must justify our work, we have to give a written explanation that proves what our work shows. So that work might be, because the slope of YZ is -3, and because the slope of xc is positive 1/3. These slopes are opposite reciprocals, therefore triangle XYZ is a right triangle. Again, since up here in the problem it said to justify that it was an isosceles triangle and a right triangle, we must have both of these things, the work and the sentence, to really wrap up our answer and be sure that we get full credit.